Hello, my name is Jeff Rush, and this talk is a demonstration walkthrough of the IPython interactive shell. Divided into 5 parts, this part 3 of the talk in the series will cover input and output history caching, viewing and editing Python source from within the interpreter, and the logging of your session. Let's begin. Now, you notice all the way here that we've each prompt has been numbered. That's the input history caching. It's keeping record of everything we've typed in here, and we can use Control P, Control N for previous to go back through things, normal read line functions like that. And we also have the arrow keys that will do the same thing. No surprises there. And we can also type in part of something and hit previous, and it will take us back through all lines in our input history that started with DEF. So it can be useful when you're like, okay, I defined something. Where was that? I don't want to see all my history. Just let me go through all the definitions here. And Control C because I don't want to change things. The last command can be found with underscore I, and underscore I was 2 commands back. Underscore II is 3 commands back. There's no 4i. You can also reference the previous history with an I and a integer, so we can go look at what was the number 1 command that we had, that we entered, and it was where we defined message flag equal 1 way back at the beginning there. And there's also a global variable where you can do subscripting here, so you could actually write programs that manipulate your input. So we can say what was the 3rd command, 0 to 3, and see that it was the definition of hello. So anyway, it's a list. You can also take a look at the history, hist command or history command, either one. And so we can do history, and it shows us the last 20 or so histories here. It doesn't show all of them necessarily, but you can see all of them. So we can say, well, show us the 1st through the 10th history item. So in the beginning of our session here, we see commands 1 through 9, because like a range in Python, it goes up from the first number up to but not including the second number. So we can see that. You'll see these underbar IP magic. Now that's because we entered magic commands, and that is the Python code that invokes the magic commands. And you usually see that, but if you want to, you can put the hist of R on there, and this will hide the magic commands. So we can actually hide the wrappers around them, and so we can actually see them as they literally got typed in. The benefit of not raw is that this lets you cut and paste these commands straight into your Python source and use them that way. You also can see the last 10 commands. Whenever the number is, it doesn't matter, just the last one number says the last n number. You can also replay them. So let's see, back up at the beginning we had message equal hello. So if we delete message, not defined, we cleared it, that's right. So it was number 3, so we can just execute number 3. And now we see that message is defined as hello. So we can use the exec with the underscore to execute any of those. You can also execute ranges, because it's a list. So we can execute the 1st through, the 4th ones are there. And it quietly takes care of that. Puts our variables back there that we deleted. Now, if you're using these often, then you might want to give them a name, because remember here we were setting up the variables here in the beginning, 1 through 4 was setting up initial variables, and maybe we want to be able to have a command that sets those up easily. So let's give them a name and call it begin, and we're going to say that it's lines 1 through 4, and also line 5, which just prints out message flag. So you can actually specify ranges with dashes, and otherwise just space and line numbers. So we put that together into a macro, and it executes the macro definition. So then we can just type in begin, and it defined those variables and also did the print of message flag there. Begin, of course, is an object in our namespace, so we can type begin 1 question mark. tells us that it's a macro. We can print begin, which actually the source is up here as well, the string form of it, right there. But we can print it, and we can store that macro into our profile. Remember the store command back at the beginning. So we store begin, and hey, next time I start this session, that macro will be there waiting for me. So I can very quickly set up scenarios. All right, viewing and editing source. And let's just go to a temp directory here and edit an object that does not exist. So I edit ABC. What does this do? Takes me into Emacs. And I left these variables around. Let's exit back out and go with DEFs. .py. So we go in here and it brings up the def.py file, and we can set it to, let's see, green eagle. Let's give it some code, and we're in Emacs here. Save it out, and we exit, and we type in whose, and we see here that we have a blue and a green. Let me reset the namespace here, because this is a nuisance. Okay, namespace is empty. Now, oh yeah, what about that that file there? When we do an ls, and we see that, oh yeah, there it is, def.py, and we can run def. Type who, blue and green are there with their values. So certainly we can edit files, any file. Just put the .py on it, and as you change directories, you edit files. Nothing special. But we can also, if you recall, from the beginning, we had those those lines at the beginning. Remember, so we can actually edit lines of input. So we had 1 through 4 and line 6, I think it was. Actually, I better make sure. So we want to edit, looking up here, 1 through 3, let's say, and 5. Edit those lines. So we just hit the line numbers. Takes us into Emacs. There's those lines that we typed in as commands. So let's change this to hello world, and not print, it echoes it anyway. Let's change it to give us the value of pi. And let's change pi to some actual real numbers here. Okay, so we edited our input history. We return. We type in whose, and sure enough, it's redefined pi and executed the command. So we can edit our history. We also have the save. So maybe we've done some history work, and we say, that was a really good test, or some work I was creating interactively. So I want to save that to a file. Let's say call Apple, and 1-3. Same syntax. Range of lines or list of lines. So I can save that out. And let's see what that was. Apple pie. So we cat it out, and sure enough, this file contains these definitions, these assignments. So we can save our history out in pieces at when we come up with good arrangements. Okay. We go back to the site, the bookmark, remember. And let's take a look at the site.py file, the less command. And as you see, it's Python source, but and we can page through it. That's nice, but I like colors. So the pycat command is a cat concatenate view source kind of thing for Python specifically. So, but it does syntax coloring. So we'll do the same thing. And hey, now we have color on our Python. Yeah, small thing, but the little thing that IPython does for us. And let's see, we did the editing of objects was as a nice one. So as we defined function ABC, prints the values, same as before. Then we want to edit that. So we say, let's just edit the XYZ function. I don't know what file it is, but let's we can edit 163. I-163. There we go. So now we can go in and play with the function here and exit, and it brings it back into our namespace. Print XYZ. Okay, it's a function. Oh yeah, the source of XYZ, p source, and we can see that the change is now in our namespace. Okay, no big deal. Now, there's another command called cpaste to paste code in. Now, you'll notice that as we were typing the definition there, that IPython was automatically indenting our source and putting little dots up there and interacting with us. But sometimes if you want to cut and paste from a website or from another place some source, you really don't want IPython interfering with your paste operation, your multi-line paste. So there's a cpaste command which puts it into an input mode, waiting for a dash alone on the line. So it's waiting for us here. We pop over to the Python cookbook, and let's see here. Let's go to the algorithm section. Pop over there. Scroll down. Let's find us a nice one here. Pythonic implementation of xrange that works not just on integers but floats and other data types. Sounds interesting. So we go to that. As it loads up, and there's the source there. Looking it over, and yeah, I'd like to play with that. So let me just pop over here to the text source, cut and paste it here out of the browser. Scroll that back up here, and oh yeah, IPython's waiting here with the cpaste command. So I'm just going to paste that in, hit the dash to end it, and the code's there. So I can type in the who and see that we now have an xrange over here. Right there. So now I can play with this and say, okay, went from 1.0 to 5.0 in increments of 0.1. Give me a range, and oh yeah, this is. Oh, I don't want an iterator. I want a list. So let's actually see the values. And there you go. So we can very easily cut algorithms off of other places and get them into IPython quickly. The other thing it does, IPython does, of course, is output caching. The results of these commands is it's been keeping track of, and one place it stores them is a variable called out. It's a dictionary. Now, not all commands result in output. Some of them just simply operate and return nothing or none. So let's take a look at the keys for the out array, the history. Okay, so all of these commands actually have some output associated with them. So we can say out, what was the output for command 118? _I. Let's try to find something more interesting here. Message equal hello. So you can anyway, you can operate on the outputs because it's just a dictionary. So we can concatenate to it outputs message equal hello with a stuck on 34 on the end of it. Now, let's see. Another thing to be aware of is if you wanted to call a function that returns something. a moment here to navigate down to my demo files. That wasn't it. That's just to find one. Could have sworn I had one, but print AB, return hello. Okay. I call it. It prints it. It also prints the return value of hello. Maybe there's a function I want to do where I say execute this thing, but I really don't want to see the return value. It's either very long or just something I don't want to. I'm not really interested in. You can finish your input with a semicolon, which says call this function and discard the return value. So here I just see the print of the A and B, but I don't see the return hello. Small thing. The log files, I don't know where I left that running. There's a log. Here is the result of our session so far. Just to return to it, just to let you know that I'm paging through the log here. It's keeping a quite detailed record. Now, one of the things you can do is you can also say run log and the name of one of these log files. You could have multiple log files, maybe other sessions you've saved and all. And it basically will go back through and execute each of those inputs. Now, I'm not going to do it here because it'll mess up the demonstration, but you can actually re-execute your log files to put you back into a certain state. And it executes each of those inputs inside a try except, so that if there was an error, say you were experimenting and it messed up, it won't stop the execution. It'll just go on past those and bring you up to date on your current state. That's it for this part 3 of 5. To download the IPython software, visit the SciPy URL given. You can send comments to me at this address. Thank you for listening.